Today is another beautiful day, and we will be talking about scandium chemistry, the chemistry of scandium. Remember that scandium belongs to the transition elements. We have discussed transition elements in our previous lectures. Now today we are going to look at scandium, which is the very first transition element, taking the atomic number 21. Remember that we had mentioned scandium, titanium, vanadium, manganese. We mentioned cobalt, chromium, nickel, zinc, iron as all transition elements in the first 10 of them in that row. Now, scandium, what is important about scandium? But do you know, interestingly, that scandium is bearing that name because of the place where it was actually being discovered. It was discovered in Scandinavia. All right, so scandium was discovered in Scandinavia, and that is why the name scandium was given to that particular metal. Interestingly, scandium is very rare here on Earth. Scandium has greater abundance in the stars, some of the stars, and the sun. So if you want to find where we have much abundance of scandium metal, you have to go to the sun or you have to visit some of the stars. That is where we find abundance of scandium as a metal. But on Earth, we have a very small quantity of scandium, perhaps the reason why we have very limited applications of scandium. Now, it will also interest you to know that scandium, even though it has little abundance on Earth, scandium has a very strong reaction with air. If scandium has an opportunity of reacting with air, it's going to do what? Transform from its silvery white color to either a yellowish color, a lighter yellowish color, or a pinkish color. So whenever scandium is exposed to air, it is going to form a cast. That is, it's going to form a sort of layer, and that layer will no more be the silvery white coloration that scandium actually carried originally, but it's going to transform from that silvery white color to a light yellowish coloration, or a pinkish coloration. So silver has very unique properties like I've just mentioned, but interestingly we also have to know that silver behaves a little bit different from other metals in that transition rule. Now, if you look at silver, for example, silver operates, or rather has, a +3 oxidation state, and this is because of its ionic radius. Silver has a very small ionic radius, and because of its small ionic radius, silver tends to behave like the rare earth metals other than aluminium and titanium. So it behaves more like the rare earth metals because of its small ionic radius, and it's the reason why titanium is it's known in its or with its +3 oxidation state. Do you know that it has some applications? But before the application, you can also do what? You can also produce or manufacture scandium metal. And scandium metal can simply be obtained by heating what? Heating scandium trifluoride with calcium metal. That is to say, if you decide to heat scandium trifluoride, if you decide to heat it, okay, with calcium metal, you are going to have scandium. Now that means you will definitely have calcium fluoride obtained. So to produce scandium as a metal, you need to heat scandium trifluoride with calcium metal to obtain pure scandium metal. Now, if you take a look at their applications, you will see that scandium is applied in very important areas. Your household equipment like the color television, scandium is used in its tube. Yes, scandium is used in your color televisions. You also see scandium being used in your energy saving lamps. We have energy saving bulbs and all those things. Scandium is used in the production of your energy saving lamps, even fluorescent lamps. Now you can also see scandium being used in the aerospace industry where planes are produced. So you see more of scandium aluminum alloy. So you see more of scandium aluminum alloy. They are used in the aerospace industry in the production or manufacturing of your aeroplanes. You can also see scandium being used even in your food, the football in our, let me say in the sporting industry. You can also still find scandium being used. Most sporting bikes, scandium metal is used in their production because of its level of stability as it operates in that post-translation state. Scandium is also used in the baseball bats. The baseball bats that you use, scandium is also used in them. So you can see that scandium is used in very important areas, even though it is quite limited on Earth. Just like we said, if you want to see scandium, much of scandium, go to the sun or go to where some of the stars. Now, we are going to look at some reactions of scandium. But before we look at those reactions of scandium, this is just a summary of what I have just discussed with you. If you take a look at this summary, you will see that scandium is Sc as its symbol. That is a symbol for scandium, and it's as atomic number 21. I've mentioned before here that scandium is the very first transition metal in that periodic row. Okay, in that row. So you see scandium, you see titanium, you see vanadium, as the case may be. Okay, so it is 21 atomic number. Atomic mass is 44.9 because it is isotopic in nature. Now, it is solid in terms of its state. It is silvery white. I mentioned that already. It is classified as a metal and not how will I put it? Not a non-metal. Okay, not a non-metal, not also a metalloid. Now, it has an hexagonal shape. If you are talking of scandium, it has a hexagonal shape. Hexa simply means it what? It means six-sided. Then it is a group 3 element. So it is in period 4, group 3. We have discussed periodic table. Check my previous classes. You will see periodic table and you will know what we mean by groups and period. They play very significant role in the reactivity of metals. And then it is also found in the D block. Of course, I told us in that periodic table that we have the S block, the D block, the F block, and we also have the P block. And that the S block were more like the alkali metals and the alkaline earth metals, while the D block were basically transition metals. So it's no more news if we say scandium is in the D block because it is a transition metal. And then its shell structure is 2892. I'm going to explain that. The electronic configuration is argon 3d14s2. Okay, so it is paramagnetic. Now, if this is the summary of scandium, what do we mean by the shell structure is 2,8? This is what we mean. So if you have this, hope this will take us. Okay, if you have this as the atomic structure, now it means that here is 2, here is 8, here is 9, here is 2. That's what we mean by the shell structure. So it means you have 2 electrons, you have 8 electrons, you have 8 electrons, you have 9 electrons, okay, and then you have 2 electrons. That is what it means. So this is the atomic structure and shell structure, if you want to put it that way, for what? For scandium. So if you understand the structure, the shell structure, you will be able to draw the atomic structure of every element you have in the periodic table. You should be able to draw it because you must know what the cell structure is. So for scandium is 2892, for titanium is 2893, and so on and so forth. Now let us look at the reactivity of scandium. How does scandium react? Now if scandium can react very well, like I mentioned before, that scandium reacts with air to do what? To put off its silvery white color to what? Yellowish or to a pinkish color. And this it does by forming a cast that will give rise to what? Scandium trioxide. So we say that from its reactivity, one, with air, scandium can possibly